All right, here we're looking at section 10.6, and our learning targets are to construct and interpret probability distributions. Then we're going to be constructing and interpreting binomial distributions. So a probability distribution is a function that gives a probability of each possible value of a random variable. So the thing I notice is that the sum of my probabilities has to be 1. So this is the probability distribution for rolling a 6-sided die. Well, I know that each of those events is equally likely, so the probability of rolling a 1 was 1/6, the probability of rolling a 2 was 1/6, and so on. And if I was to add all of these up, I would get 1, so I know that my probability distribution is correct. So here's our first example. Let x be a random variable that represents the sum when 2 6-sided dice are rolled. Make a table and draw a histogram showing the probability distribution for x. So if I look back, this is what we can see when I roll those two 6-sided dice. These are all of my possibilities, right? So I can draw these out and label them out, or I can just go based on what I've known in the past, right? So the first thing I want to do is I want to make a table. So my possible values, because we're dealing with the sum, right, are from 2 to 12. I can never get a 1 if I'm rolling 2 dice. I can only get from 2 to 12. So now my table is going to show how many outcomes of rolling 2 dice produce each value of x. So then I divide it by 36 to find the probability. So there's one outcome where I can get a sum of 2, right? Both of my dice have to be 1. So that's 1 out of 36. There's 2 possibilities where I can get a 3, and so on, and I continue to fill out my table, and I divide that number by 36, and then I simplify my fraction. You'll notice if I was to add all of these fractions up in the denominator, they would equal 1. So here's my probability distribution. So the next step, I was asked to draw a histogram where the intervals are given by x and the frequencies are given by this p of x, my probability. So here's my histogram. You'll see that my sum of my dice, my intervals are down here for 2, 3, 4. This is the sum, and my probability. Okay, so now I've done what I was asked to do. I was figured out how many outcomes satisfy the condition, and then I figure out the probability, and I want to kind of leave these as fractions. I found the probability of that happening. Then I can just use this to draw a quick histogram. Okay, so now we're going to be using that distribution from example 1 to answer these questions. So what is the most likely sum when rolling 2 6-sided dice? So I can either look at my table or my histogram and see what is the largest probability, right? The closest to 1. And we always want to go the closest to 1 is the most likely to happen. Well, I see using my histogram, because it's a drawing, that I see that the sum of 7 is the most likely. Okay, so I can see that either in the table or my drawing. So then I have to figure out what is the probability that the sum of the 2 dice is at least 10. So I can look and see, well, I'm dealing with these 3 columns over here because I've got at least 10, so 10, 11, and 12, and then I can deal with the probabilities there. So I want to add those probabilities up. So the probability that x is at least, right, greater than or equal to 10, is equal to the probability of x equals 10 plus the probability that it's 11 and plus the probability that it is 12. So then I substitute my values from my chart from before, and then I solve, and I end up with 6 over 36, and I simplify. So my probability is approximately 16.7% that the sum will be at least 10. So I can come up with this without using my histogram and my table, but it's much easier once I've already done that step. So now here's your first monitoring progress. See how you do. So now we're talking binomial experiments. This is our second learning target. So a binomial experiment meets the following conditions. Remember, bi meaning 2. So there are n independent trials. And remember, independent means they don't have anything to do with each other, and so I can look at them as all results just separately. So there are n number of independent trials. So each trial has 2 outcomes, right? This is where the binomial comes into play. It's either a success or it's a failure. So the probability of the success is the same for each trial, and this probability is denoted by p, right? So probability for success is p, and then probability of failure is what's left over, so it's 1 minus p. So my binomial experiment, the probability of exactly k successes in n trials, k and n just tell us how many we're looking at. So again, right, I'm using my combinations, and I've got some exponents. So let's look at this. This is something you're going to need to write down, this experiment and this equation, because we're going to use it often. So now let's look at an example. So according to a survey, about 33% of people ages 16 and older in the U.S. own an electronic book reading device, or e-reader. You ask 6 randomly chosen people ages 16 and older whether they own an e-reader. Draw a histogram of the binomial distribution for your survey. So now let's figure out what I know and what I'm looking at. So I know that my probability that a randomly selected person has a p-value, right, my probability is 0.33, because that's what I was told. I turn it from a percent to a decimal. Because I survey 6 people, my n value was 6. So now I can plug in what I know. So the probability that k is 0, right, because there is a possibility that none of the people I ask own that e-reader, so I have to include 0. So I find my combination of 6 total people with 0, my 0.33 to my 0, and then my 6 minus 0. So there's that probability. Then I find the probability that k equals 1, and then I find the probability that k equals 2. And I come up with these and see what I end up with, right? So here, these are telling me 0 of the 6 people I survey own that e-reader. 1 person does, 2, 3, 4, 5, and all 6. So again, I'm using my combinations, and you'll see again, just like we were dealing with our binomial theorem, this first exponent goes up 1 every time and is the same as my k value. This second exponent decreases and is 1 minus my k value. So now that I have all of my probabilities, now I can draw my histogram, right? And I'm going to use my probabilities here as decimals because that's what I found out here. And I use decimals here because I'm dealing with percents in the question, and so I go ahead and I use my decimals. So now I just draw my number of people that own the e-reader, and I fill in the numbers that I get from my probabilities. And here we're going to get as close as we can because it can't be, not all of these are going to be exact values. Okay, so now we're going to be interpreting that binomial distribution, right? This is example number 4. So we're going to be using that binomial distribution to answer each question. So what is the most likely outcome of the survey? So if I look back at both my probabilities, right, or my histogram, that can tell me all of my information that I need. So the most likely outcome is greatest for k equals 2, so that 2 people out of the 6 that I survey have an e-reader. That's just my most likely based on the data that I found before. So then what is the probability that at most 2 people have an e-reader? Okay, so I'm looking at the probability that k is less than or equal to 2. So at most means less than or equal to. So I have to find the probability of 0 and 1 and 2, which I did back on the previous example. So now I just find those probabilities, and since these are always independent events, I can just add them together. And I find that my probability is about 68.6%. Things would be different if these were dependent, but they're not dependent events. They're all independent events. So here's this last monitoring progress. Try it. See how you do. This is a pretty short section, so you want to make sure that you get this pretty easily. So now let's look back at our learning targets. So the first thing was construct and interpret probability distributions. And those distributions we usually want to look at in a table. It's just easier to see that. And then we also used a histogram. Then we were able to construct and interpret binomial distributions. And remember that the difference here is that a binomial distribution has either success or it has failure. And we can use pieces of our binomial theorem to help us figure out the probabilities and the numbers that we're going to be dealing with these distributions. So now I want you to go ahead and try your homework for 10.6.